So next, we're going to go over this video. I want you guys to watch this video. Really keep in mind everything that we've talked about so far. This video does a really good job of tying all these concepts today that we've talked about together. And so anything that you had any doubts on during the lecture, I want you to take notes on and remember to draw things so you can remember. Okay, we're going to watch this together and be walking around. Make sure you have your notebooks out and are taking notes and diligently listening. All right?
Imagine that one day, all of the clocks and computers on Earth broke, and all the calendars disappeared. How would you keep track of how much time had passed? Well, you could look to the moon. Humans have used the moon to keep track of time for thousands of years. It isn't a coincidence that the word moon is related to the word month in Old English. The moon is Earth's only natural satellite. A natural satellite is a naturally occurring body that orbits a planet. Some of the planets in our solar system have more than 50 satellites or moons, but the Earth just has one. The moon does not generate its own light. We can see the moon from the Earth because it is partially lit by the light from the sun. In fact, moonlight is just sunlight reflected from the moon onto Earth. The moon takes about 27 days to make a full orbit around Earth. And as it does, the lit part of the moon appears to change shape to us here on Earth. These shapes are called the moon phases, or lunar phases. So why do we see different lunar phases? Well, the 27 days it takes the moon to orbit the Earth once is the same amount of time it takes the moon to rotate on its axis once. This means that the same side of the moon is always facing us. At the same time, the sun always lights up half of the sphere of the moon. However, the side of the moon that's facing us isn't always the same part of the moon that the sun lights up. This causes the moon to appear to have different shapes or phases in the sky depending on the time of the month. Let's take a closer look at the moon's phases. First, we have the new moon, which happens when the moon is closest to the sun in its orbit. During this phase, the lit side of the moon is completely facing away from Earth, so it looks like the moon has disappeared. In a day or two, we'd be able to see a little sliver of moon in the sky. Over the next few days, the crescent moon will appear to get bigger and bigger. When the moon appears to get bigger from one day to the next, we say that the moon is waxing. So this phase of the moon is called the waxing crescent moon. You might notice that sometimes we can still see the rest of the moon in the shadow. This is because the Earth reflects sunlight onto the moon, just like the moon reflects light onto Earth. Eventually, the moon appears to change shape so much that it isn't a crescent anymore, but a half circle in the sky. This is called a first quarter moon. There are two ways to think about why this phase is called a quarter moon, even though it looks like the moon is half illuminated. The moon is a sphere, so we can only ever see half of the moon from Earth. During a quarter moon, the moon forms a right angle with Earth and the sun. This means that we see a half-lit portion of the half of the moon that's always facing us. It's half of a half, so it's a quarter. Also, a first quarter moon occurs when the moon is a quarter of the way through its new cycle. Next, there's the waxing gibbous moon. The word gibbous comes from the Latin word meaning humpback. Once the moon is farthest from the sun in its orbit, the full sunlit side of the moon faces Earth. We call this phase the full moon. But the moon is not done yet. It's only finished half of the cycle. Next, we have the same phases, but in reverse. As the moon appears to get smaller and smaller, we say that it's waning. The full moon appears to shrink, and then we see a waning gibbous. Then there's the third quarter moon. This happens when the moon is 3/4 of the way done with its cycle, and the moon forms another right angle with the sun and the Earth. The moon appears to shrink even more, and it becomes a waning crescent. And the cycle starts anew, with another new moon. Even though the moon completes an orbit every 27 days, the lunar phases actually repeat about every 29.5 days. This is because the Earth is revolving around the sun while the moon completes its orbit, so the moon has to travel a little extra to catch up. The moon isn't just something beautiful to look at in the sky, or just an easy way to keep track of time. The moon's gravity controls the tides, which are the rise and fall of water in oceans, lakes, and rivers. Tides allow for unique ecosystems, like tide pools, to exist, and we can use the tides to create electricity in tidal power plants. The moon also helps keep Earth's axis stable. Without it, our planet would wobble more dramatically on its axis over long periods of time, which would change up our weather and our seasons. So even though your calendar is pretty unlikely to spontaneously combust tomorrow, you can still thank the moon for being such a stabilizing influence and good companion to our planet.
Okay, good. So that video really summarized a lot about what we talked about. And let's go ahead and continue here. So next we're just gonna talk briefly about eclipses, okay? So eclipses, there are two kinds of eclipses, a solar eclipse and a lunar eclipse. So let's start with the solar eclipse. A solar eclipse occurs when the moon passes between the sun and the earth, okay? So when the moon is right here in relation to the earth and the sun, that's when we have a solar eclipse. So maybe you guys have heard of the solar eclipse, and what happens is that the moon casts a shadow on the earth. And depending on where you are in the earth, whether you're in the northern hemisphere or the southern hemisphere, or even specific parts of the earth in the northern hemisphere, for example, in the United States, you know, that shadow isn't as big as it makes it seem on this picture. It's relatively small. So in some parts of the earth, you might only be able to see partial shadows, but the track of which the solar eclipse passes, sometimes you're lucky and you get right to be in that full shadow in the solar eclipse. So that's a really cool event that, you know, we get to witness here on Earth, and you got to wear some kind of special glasses to make sure that you aren't harmed, because the sun is still directly behind that, so you don't want to burn your eyes or cause any damage to your vision. So that's a solar eclipse. Remember, when the moon is directly between the sun and the earth, okay? A lunar eclipse occurs when the earth is between the sun and the moon, okay? And so that happens when you see the light's rays are basically all blocked out by the earth itself, and so you have an eclipse, a shadow on the moon, okay? Now, same thing, the position on Earth is what's going to allow you to see that lunar eclipse. Here's another cool thing that I wanted to show you guys, and this is another tool that actually tells us when the upcoming eclipses are, whether they be solar or lunar eclipses. So then this is a site from NASA, and so you can see here, so get ready for these upcoming eclipses in the United States. So again, like I said, it's very relative to what position you're in, where you live, if you're able to see some of these eclipses. So you can click, you know, your annual solar eclipse or a total solar eclipse here. So let's just click on that, April 8th, 2024. So that's when the next one is going to be crossing North America, passing over Mexico, United States, and Canada. So that's really cool. Just another cool site if you're really interested in the moon. And these events, you know, don't happen as often as a regular lunar cycle or anything like that. These are some more rare events, and so it's really cool to be a part of that and be able to see that. So let's go ahead and wrap up here. So just a quick little recap, okay? All the questions we did on our pre-test, we have gone over and gone through during the lesson, okay? A couple things that I want you to check your notes on and make sure that you have in your notebooks for the moon phases. The moon phases have the lunar cycle has 8 phases, okay? 8 phases. Know how long a lunar cycle takes to complete. So again, 29.5 days. If you didn't get that, write that down. Be able to identify a specific moon phase on a diagram. Okay, so that's why I kept telling you guys, draw it in your notebooks, because this is how you're going to remember it. Tides. The moon's position affects Earth's seas. And remember, like it said in the video, it's not just the seas, but also rivers and any bodies of water on the planet. Sea bulges, or high tides, are created by the moon's gravitational pull. Remember? So we had that diagram where the moon, wherever it was closest to, that's where it was causing the high tide, and directly opposite of that location. And then eclipses. Know the difference between a lunar and a solar eclipse, and be able to identify the type of eclipse based on a figure. Okay? So remember the solar and lunar eclipse and where the position of the sun and the moon and the earth are and why it's caused. Okay? So, excuse me. So thank you for paying attention today. Thank you guys for following directions. And now I want you to put your notebooks away and take out a pencil. We're gonna do a quick little activity to finish up, and I want you to get together with a partner. So while I prepare this, you guys pick a partner quietly, get together and sit together, okay? Let me pull this up. Okay, is everybody seated with their partner? Good, good. So now I have this up here, the moon phases, which I'm actually going to be handing out to you guys. And so what I want you to do is use this diagram, and your notes and your partner work together to draw the different phases of the lunar cycle, okay? You can draw it, color it in, shade it in, whatever you want. And so I'm gonna give you guys a couple of minutes to do that together with a partner, and then we're gonna wrap up by doing the post test, which you all should have kept out because that is your exit ticket, okay? So I'll give you a couple minutes to do that. If you have any questions, I will be walking around the room and you can ask me whatever you need. Good. So at this time, it seems like everybody is done with your worksheet, okay? I want you to hand those in. Actually, I'm gonna go ahead and collect those. And while I'm going around collecting those, I want you guys to finish your post test, okay? And that is your exit ticket. You're gonna hand that to me on your way out of class. So the post test, again, same questions. You should have all the answers this time. How many phases are there in the lunar cycle? Number 2, how many high and low tides normally occur during one day? Number 3, how long is the lunar cycle? Number 4, what term refers to when the moon is growing in size? And number 5, what term refers to when the moon is shrinking in size? So let me go ahead and collect your worksheet papers while you guys get those exit tickets done. All right, so I'll give you a little bit more time on the exit ticket you guys got, the post test, and then we're going to address our homework for tonight. Okay, if everyone's all done, I'm going to go ahead and tell you guys what you're going to be doing for your homework tonight. Your homework is going to be to go home and observe the moon tonight. I want you all to go and observe the moon tonight and use the knowledge that we talked about today to not only determine what the moon phase is of the moon that you're observing, but I also want you to draw it and bring that into class tomorrow, okay? I want you to be specific and I want you to use the correct terms that we went over in class today. All right, so if we all don't have any more questions, I guess that concludes our lesson for today. Thank you again and have a good day.